Picture a swirling crown of icy air above the North Pole, a vast, invisible force that shapes the very nature of winter across the northern hemisphere. This crown isn't made of jewels or gold, but of frigid, whirling winds that circle the top of our planet, high above the frozen Arctic landscape. This is the polar vortex, a colossal ring of cold, fast-moving air that forms a barrier between the Arctic and the rest of the world. It's a phenomenon that exists every winter, but its power and reach can change dramatically from year to year. Imagine it as a vast, spinning river of wind, circling the pole and locking the coldest air over the Arctic during the long, dark winter months. This river of air is constantly in motion, shaping the weather patterns far below. When the polar vortex is strong, it acts like a fortress wall, keeping the bitterest cold contained in the far north. This means that Europe and North America often experience relatively normal, even mild winter conditions, with fewer outbreaks of extreme cold. But the strength of the vortex is not constant. It can shift and fluctuate, sometimes dramatically from one winter to the next. These changes are the key to understanding why some winters are harsher than others. A strong vortex is a tight, circular flow, almost like a spinning top, that keeps the cold air locked in place and prevents it from spilling southward. When this happens, the jet stream, a fast-moving ribbon of air that guides storms and weather systems, remains straight and steady, allowing for predictable winter weather. The polar vortex actually exists in two layers of our atmosphere: the troposphere, where our weather happens, and the stratosphere, which sits 10 to 30 miles above the ground. Meteorologists pay special attention to the stratospheric vortex because changes up there can have dramatic effects down here. When the upper stratospheric vortex is strong and stable, it reinforces the orderly flow of winter weather below, helping to keep the cold air bottled up in the Arctic. But when the vortex weakens, due to natural variability or sudden warming events, the jet stream begins to wobble and become wavy, losing its straight path. This breakdown in the vortex's strength allows frigid Arctic air to escape, surging southward into North America, Europe, and Asia. Suddenly, cities that were enjoying mild winters can be plunged into deep freezes or hit by unexpected snowstorms. Meteorologists call this event a polar vortex disruption. It's a dramatic shift that can catch even seasoned weather watchers off guard. It's important to understand that the vortex itself doesn't move over your city. Instead, it weakens, and the cold air it usually traps is released, spilling southward and bringing with it the potential for extreme winter weather. These disruptions can transform a typical winter into one of wild extremes: blizzards, deep freezes, and even unusual winter floods, affecting millions of people across continents. That's why understanding the polar vortex is so crucial. By studying its behavior, scientists and meteorologists can better predict when winter might take a wild turn, helping us prepare for whatever the season may bring. The most dramatic and impactful disruptions to the polar vortex are triggered by a phenomenon known as sudden stratospheric warming, or SSW. This rare but powerful event can completely transform the course of winter weather, not just in the polar regions, but across much of the northern hemisphere, including Europe. In just a matter of days, temperatures in the polar stratosphere can soar by up to 50 degrees Celsius, an astonishing and rapid increase that is almost unimaginable in such a cold and stable part of the atmosphere. This sudden warming is one of the most extreme temperature changes found anywhere on Earth. This dramatic shift happens when powerful atmospheric waves, generated by the interaction of strong winds with mountain ranges and the sharp contrast between land and sea, surge upward and crash into the stratosphere. These waves act like invisible hands, pushing and pulling at the polar vortex from below. As these waves disrupt the vortex, they slow its spin, weaken its structure, and can even split it into two separate swirling masses. This breakdown of the polar vortex is a key ingredient in unleashing wild winter weather. The jet stream, which flows far below the stratosphere, becomes distorted and wavy in response. This sets the stage for extreme and unpredictable weather patterns, as the jet stream's usual path is thrown into chaos. The effects of an SSW begin high above the Earth, but it takes days or even weeks for these changes to work their way down to the surface. As the altered circulation descends, it gradually reshapes the weather we experience on the ground. As the weakened circulation sinks, it reshapes the jet stream, carving out new and unusual pathways for both cold Arctic air and milder southern air to travel. This can lead to dramatic shifts in temperature and weather across entire continents. A classic outcome of a major SIW is the formation of a blocking high-pressure system over Greenland or Scandinavia. This block acts like a giant atmospheric roadblock, halting the usual flow of weather systems. This block jams up the normal west-to-east movement of weather, causing systems to stall and linger over Europe for days or even weeks. Instead of the usual mild Atlantic air, frigid Arctic winds are able to sweep down into Europe, bringing a surge of cold that can be both sudden and severe. The result is often prolonged cold spells and heavy snowfall across the continent, transforming cities and countryside alike into winter wonderlands, or for some, winter nightmares. SSWs are rare, occurring only every few years, but when they strike, they have the power to reshape an entire winter season, leaving a lasting mark on weather records and memories. That's why meteorologists keep a close watch for signs of SSWs, treating them as the ultimate signal of potential winter upheaval, a warning that the atmosphere is about to turn the season upside down. Polar vortex disruptions aren't random events that just happen out of nowhere. Instead, they're shaped and influenced by powerful global climate patterns that operate on a massive scale, connecting distant parts of the world through the atmosphere. Two of the most important players in this global drama are the El Niño Southern Oscillation, or ENSO in the Pacific Ocean, and the North Atlantic Oscillation, or NAO, which dominates weather patterns over the Atlantic and Europe. La Niña, which is the cool phase of ENSO, brings colder than average sea surface temperatures to the central and eastern Pacific. This shift increases the odds of a weaker, more easily disrupted polar vortex high above the Arctic. La Niña also changes where and how much rain falls in the tropics, which in turn alters the atmospheric waves that can travel northward and destabilize the polar vortex, making it more likely to break apart. As a result, winters with strong La Niña conditions often see more sudden stratospheric warming events, dramatic temperature spikes in the upper atmosphere that can trigger cold outbreaks at the surface. Closer to Europe, the NAO measures the difference in air pressure between Iceland and the Azores. This pressure difference acts like a dial, controlling the strength and path of the jet stream across the Atlantic. When the NAO is positive, it brings mild, wet, and often stormy winters to northern Europe, with frequent rain and above-average temperatures. But when the NAO turns negative, the jet stream slows down and meanders, allowing frigid Arctic air to surge southward into Europe, sometimes bringing heavy snow and prolonged cold spells. Disruptions in the polar vortex often push the NAO into its negative phase, locking in cold conditions for weeks at a time and making winters harsher and longer. In essence, La Niña loads the dice for sudden stratospheric warmings, and those SSWs make a negative NAO and therefore a cold European winter much more likely. These climate patterns don't work in isolation. They interact and reinforce each other, setting the stage for some of Europe's coldest and most memorable winters. By understanding how La Niña and the NAO work together, forecasters can better anticipate the biggest winter risks and help communities prepare for whatever the season may bring. Looking ahead to winter 2025-26, several warning signs are flashing. Climate models predict a strong La Niña, a key ingredient for vortex instability. The quasi-biennial oscillation, QBO, is also expected to be in its easterly phase, further weakening the vortex. Low Arctic sea ice and heavy Siberian snow cover could amplify the risk. These factors don't guarantee a disruption, but they make one much more likely. Meteorologists are watching closely, as the odds of a major SSW are higher than average. Europe could be facing a winter with a real chance of prolonged, severe cold. If a major vortex disruption hits, northern Europe will be first in line for a deep freeze. A blocking high over Greenland or Scandinavia would cut off mild Atlantic air. Instead, icy winds from Siberia, the infamous beast from the east, would sweep in. Temperatures could stay below freezing for weeks, even in cities like London or Dublin. Scandinavia and the Baltics would see even harsher, longer cold spells. As the dry Siberian air crosses the North Sea, it can trigger heavy sea-effect snow in eastern Britain and around the Baltic. The 2018 beast from the east brought chaos. A repeat could be even more severe. Ski resorts might see record snow, but the cold would test infrastructure and daily life. Northern Europe must prepare for a classic, relentless winter. Central and Eastern Europe become a battleground during a vortex disruption. Frigid Arctic air clashes with milder southern air, creating sharp weather contrasts. The coldest air often plunges into Poland, Germany, and neighboring countries, bringing deep freezes and straining energy supplies. Where cold meets warmth, heavy snowstorms erupt, paralyzing travel and threatening avalanches. Cities like Berlin and Prague could face repeated snow emergencies. Further east, Ukraine and western Russia endure the most severe, prolonged cold. The winter of 2012 saw temperatures below -30 degrees Celsius. A similar scenario is possible. For millions, it's a test of resilience against winter's harshest extremes. While the north freezes, southern Europe faces relentless storms. A wavy jet stream steers Atlantic storms into Spain, Portugal, Italy, and the Balkans. Expect a wetter-than-average winter with flooding and landslides in vulnerable areas. Mountain regions like the Apennines and Dinaric Alps could see record snow, boosting ski resorts but raising avalanche risks. Persistent rain and cloudiness could harm crops and delay spring planting. The main story for the south, not cold but water, floods, storms, and heavy mountain snow. The contrast with the frozen north will be stark. Southern Europe must brace for a winter of water-related challenges. A polar vortex disruption impacts every part of daily life. Travel grinds to a halt, airports close, roads and rails are buried in snow or ice. Energy demand soars, straining power grids and risking shortages. Agriculture suffers. Crops can freeze in the north or drown in the south. Livestock need extra care and food prices may rise. Tourism splits. Ski resorts thrive, but other destinations struggle with cold or rain. Public health risks increase from frostbite to floods. Emergency services must be ready for anything. The ripple effects of a disrupted winter touch everyone. Despite the warning signs, winter's outcome is never certain. Meteorology deals in probabilities, not guarantees. Scientists will monitor the polar stratosphere daily, using satellites and weather balloons. Early signs of an SSW can give weeks of warning, allowing time to prepare. Not every cold snap is caused by the vortex, but SSWs bring the most persistent, widespread impacts. Staying informed is crucial. National weather services will provide updates and alerts. The best advice: don't panic, but be ready for a winter that could be anything but ordinary. Preparation and awareness are the best defenses against nature's surprises. As the season approaches, all eyes will be on the skies.